Okay, next up, hopefully Mike's on the line.
Hey, Dave. Yeah, this is Mike. Can you hear me okay?
We can hear you. Let me get your slides up, and then I'll drive as you talk, and there might be a little delay. So
Okay.
Mike Monahan of SNK Global Solutions is talking on CFS-based autonomy requirements tester. Just a second, Mike.
Yep. Yeah, and thanks, you guys. I'll just kind of get started or warm myself up a little bit so I can go through this quickly. I know it's late in the day for you all, so try to keep this relatively short. I am here in the snowy Midwest, West Michigan, so I was hoping to be in Pasadena with you all, but we got grounded trying to leave last night, so I'm doing this remote instead.
Okay, we got your slides up, and we're going to slide one.
Okay, looks like there's a little bit of delay on my YouTube or my view, so let me just, oh, there it goes.
Yeah, there'll be a
Pull up
delay.
mine. Okay, looks like it's coming up now. You guys see it all, Dave?
Yeah, we're good.
I'm behind you a little bit. Okay, sorry. So this is just playing catch up. Okay, you can go to the next slide. So I will follow along on my end because I'm not going to keep up with you all. So if we're looking at slide 2, this is just the kind of the obligatory sheet about SNK Global Solutions.
Okay, sorry. We went to slide 3. I thought you meant one more. Okay, now we're on slide 2.
Sorry. So, like I said, this is kind of the obligatory sheet about us. I think some of you all are probably familiar with us. We've been working down at JSC for quite some time, and I presented at last year's conference as well on the cFs workshop. Next slide. So let me, I guess, start by giving you guys a little bit of background for kind of why I'm interested and was hoping to be there. So I think some of you folks remember we presented on our user survey last year. So what we did is went out and looked at a bunch of issues related to the user community with cFs and tried to come up with some areas for us as kind of an external party to engage with the community and try to add some value. So quite honestly, listening to as much of today as I could, I am really encouraged with where the community has gone. In particular, some of the comments from Mike Aguilar earlier on today, as well as a lot of the discussion I've heard since then. So if you'll notice, 2 of the bullets listed out of our survey have been addressed today. Testing has been addressed extensively, and I will talk a little bit more about that. As well as the command and telemetry bullet, which I was not aware of. So it sounds like Lori's team is doing some good work in that area as well. So in general, if nothing else, this just validates that you guys are certainly going the right direction. And I think things are going well in terms of the general cFs ecosystem, if you will. Next slide. So what we have done, we've taken a little bit of a different tack, and I'll try to keep this as relevant to you guys as possible. We proposed some SIBRs last year related to cFs, and the direction we went was that we looked at the autonomous systems and robotic systems community, and went after some research in the area of autonomy testing primarily. So what we have done is developed some autonomy testing tools or a toolkit that really leverages cFs because of the pub/sub architecture and because some of the unique characteristics of the software. So what we've really done is been working on describing some approaches for autonomy testing that really focus on taking the requirement, moving all the way through the testing process, and really keeping a tight loop in terms of test-driven development with autonomous systems. Next slide. And I'm going to try to go through these a little bit quickly. I should also tell you all that I am not the PI or a technical expert, so I can't answer questions, and hopefully I won't butcher this presentation on behalf of our PI too badly. I believe he is listening. But so essentially where I was going was that we are really focused on the difficulty associated with designing tests for autonomous systems. And there is kind of it's a Pandora's box to try to get into why that's difficult. But the more complex the scenarios become that these autonomous systems can confront, the more difficult it becomes to define tests that can capture those potential scenarios and help us assess the capabilities of those systems. So that's really what our focus is in terms of this SBIR. And like I said, we're leveraging cFs because it's such a great architecture for what we're trying to do. So this image really just represents the goal is really to keep as close to the autonomy requirement as possible as we move into the testing process. Next slide. So this image really shows what we're doing that's, I think, relevant to this community and something I think I would like to talk more about based on some of the other stuff I've heard today. But what we've done is really develop this test runner app, which is essentially a cFs app that's designed to provide sort of a generic test runner capability for autonomous systems. So essentially what we're trying to do is provide an app that can be genericized to a large degree, and then we can run tests through the test runner to test the overall system and the autonomy apps within that system to make sure that we're getting the kind of behavior that we expect out of those new cFs apps related to autonomy. Next slide, please. So really the goal here is to develop an entire sort of toolkit, if you will, related to autonomy testing, and developing the test runner was really a critical component of this overall process. So a key part of our phase 1 research was to prove out that this test runner was possible and was going to provide the kind of testing capability that we were after. So that's really where we focused in terms of phase 1. The other components of this package include a requirements handler and a test handler. So there's going to be more pieces, if you will, that are going to take the overall app testing process from the original requirement all the way through the test for the kinds of autonomy behavior that we're looking for. Let's see. Next slide. So we've decided, or not decided, but we've been working with Johns Hopkins Applied Physics Lab on this work. So they have been a partner of ours through the phase 1 process, and partially for a variety of reasons, but partially because it is a cFs project, we have been using Solar Probe Plus type requirements for our design reference, if you will, for the autonomy that we're trying to develop the test toolkit, for. So we've really focused on Solar Probe Plus for a couple of reasons, mostly because it's already cFs oriented, as well as the fact that it's got a really robust autonomy app that is part of that overall system. So it's a kind of a low level of complexity, if you will, autonomy, and it was a really appropriate subject for this research. So what we've discovered, and I'll try to go through this a little bit more quickly, is that because of the nature of testing or of developing autonomy requirements, we can develop some templates that are potentially really powerful in terms of generating the requirements and moving those through the testing process. So let's go to the next slide. And so the next series of slides really just show some of the data models that we've developed as part of the template. And really what we're seeing is a lot of similarity in terms of the way that faults are managed in these autonomous systems. And we think that that provides a real good springboard to develop some templates, leveraging some standards that we think are going to be super helpful in terms of developing better testing capability and making sure that the requirements that we originally start with are represented and accurately tested throughout the development process. So you can go through the next set of slides relatively quickly. These are just different data models that we've developed as part of the test spec and the test plan that's part of this testing toolkit. So why don't we skip down to, a lot of this stuff is really not CFS oriented. Why don't we skip down to slide 15? And I'll try to wrap this up a little bit. So I think I've talked about what our real focus has been. What we really are trying to do is develop some tools leveraging cFs. We think there's some good application for a broader cFS community, especially if the test runner is as genericizable as we think it is. So we think that we're going to come out of this with a pretty solid app that needs to go back after listening to today into the catalog. And Susie, I'll be sure and chat with you about what we're doing in more detail so you can capture some of this stuff, if it is in fact as relevant as we think it is. And so that's where we hope there's some value in terms of the work we're doing. The next stage or the next phase for us is to complete the other pieces of the toolkit, so develop a requirements handler and a test handler that will give you a really robust requirements testing capability that will all be cFS. So we think there's going to be some additional pieces of this toolkit that will add some value as well, especially for robotic and autonomous systems developers. And then we're going to move into sort of more complex integration testing and some of the challenges associated with testing autonomy requirements in those more complex environments. I heard some discussion earlier today about state machines, some of the electronic data sheets discussion. I think you guys mentioned state machines and some of the capabilities associated with testing through state machines. So we know that's a direction that we're going to head, and we know that's a direction that some of our DoD customers are interested in as well. So we're going to be looking at ways to do more complex autonomous systems testing, all within sort of this basic framework, starting with really making sure the requirements drive the testing throughout the development lifecycle. Next two slides are sort of a plug for the other half or side of our work, which is looking at the fault management end of the spectrum. That's also particularly relevant with the autonomous system stuff. So we also have a second phase one SIBR that is looking at how to represent fault management in highly complex systems and ways that we can make fault management information more valuable for software developers as they develop complex systems. So the next slide is another sort of system concept for the FM viewer. And I will stop there and try to give you guys back a little bit of time. If there are questions, I'll be happy to take them. Like I said, I'm not the expert, so I'll do my best. But I'm sure I won't give you the answer you're looking for. But
any questions? Okay. Well, thank you, Mike.